Okay, so another example of horizontal projectiles. So we've got a particle projected horizontally with a velocity of 15 meters per second. We want to find the horizontal and vertical components of displacement of the particle from the point of projection after 3 seconds, and then from there we'll be able to calculate the distance of the particle from the point of projection after 3 seconds. Okay, so in part A, let's just start by thinking about the things that we know to do with this projectile. So we know that we've got a horizontal velocity of 15 meters per second, initial velocity. The vertical, the initial velocity is 0 meters per second. The acceleration horizontally is always 0, because the only force is the weight of the particle, so that does not affect the horizontal, that only affects the vertical. So the acceleration in the y direction is minus 9.8 meters per second squared. In both cases we're talking about 3 seconds, so t equals 3. And we're trying to find displacements for both, so we can try and find sx something and then sy, which will be something. So the form we use is s equals ut at a half at squared. And we can substitute in both sets of values and then find answers from there. So for sx, it's just going to be 15 times 3 plus 0, so that's 45 meters. For sy, it's going to be 0 times by 3 plus a half times minus 9.8 times by 3 squared, which comes to minus 44.1 meters. Okay, so those are the two answers to the questions. So the minus means that's gone downwards, which you'd expect because it's being pulled down by gravity. Part B then just wants the distance of the particle from the point of projection. Well, what's happened is it's gone 45 meters here. It's also gone 44.1 meters downwards. What we want to work out is the distance here. So it's just a case of using Pythagoras to find that. So d squared is 45 squared, add 44.1 squared, and then we can just calculate that, and that comes to d being 63.0 meters, and that's that.